Hello everybody, we're going to get started here in just a minute. Give another minute or so for some folks to hop on. And I can kind of give a quick overview for you folks that are on already. We really appreciate you joining us today. My name is Zach Parnell. I'm the VP of Operations here at ITI. For you that are new to ITI, we are Industrial Training International, as you can see, world leader in crane and rigging training. The demo today is really interesting. I'm going to kind of touch on what we've been doing with this showcases and before I turn it over to Mike here. But this is much more of an interactive demo, and I hope all of you see the message right here to download the workbook. So you're going to need that workbook to participate in the showcase today. It'd be really handy if you can print it out and have some pencils nearby. Okay, well, let's get started. So for all of you that are joining us, I'm just happy to say hello and good morning. It's 11 a.m. here on the west coast of the U.S. We have some folks from all around the world today joining us, and some might be light out, some might be dark out, so welcome. ITI, again, is a world leader in crane rigging training. We specialize in those two items specifically. We don't sell any product. We don't sell rigging or anything like that. We are an education company, and we're happy to do this once a month. This is basically the showcase webinar series, and what we try and do is bring some insights to customers and prospects that are interested in learning about the industry and about ITI. But as you can see, some of the industries that we serve, as you all know, crane and rigging activities span across dozens of industries. So we are doing the trade training, if you will, for dozens of industries and are key providers for a lot of major customers around the world. And just to touch on that, I want to give some shout outs to some folks that are here from customers including Alstom Power and Argonne National Labs, BHP Billiton and BP. We also have some folks that are new, and we met, let's see, BAE Systems. Hey Steve, you're here from Norfolk, I think. And Mike gave me a document before he was interested because there's actually 25 countries represented here today, which is the most we've ever had. There's folks from Saudi Arabia, South Africa, India, Britain, Nigeria, Philippines, Australia, etc. So in addition to that, North America, there's 40 states, represented in the U.S. and 6 provinces in Canada. So like I was talking about the Showcase webinar series, you guys can all go down to iti.com/showcase and download, well, actually just watch from a web page the past presentations, okay? Those included cranes rigging your organization, effective crane rigging training methods for your employees, heavy intermodal lift and transport. This was a really neat one we just did last month with Barnhart's Jim Yates, their Senior VP of Engineering. Today, of course, we're doing a Master Rigger overview. Like I mentioned, again, go to the web page if you need to download the workbook. And then upcoming, we have lift planning considerations in August, and then ASME B30 and P30 developments. And a major reason we're doing the ASME developments webinar, your presenter today, Mike Parnell, he's the vice chairman of the ASME B30 committee. So a lot of customers call us to know a lot of times to understand the legislation and the standards, and also the P30 is the committee that oversees lift planning. And that standard, I believe Michael touched on, but it's coming. I don't think it's published yet. It's coming out soon. They've been working away all year at it. But as you all know, ASME standards are accepted very much so throughout the Western Hemisphere, U.S. and Canada especially. And Mike is a industry leader in our industry, obviously, and his focus points are on wire rope and rigging. He's an expert witness on a lot of wire rope and rigging accidents, and he'll probably touch on some of those as we go through the workshops today, as a lot of them apply to rigging selection, load control, and the like. So I'm going to turn it over here to Mike while we get started. But the idea of the purpose of the course or this webinar is to go over the course and why we conduct the Master Rigger course as we do. And we're going to give you all pretty much half or 60% of the workshops. I'm sorry, the webinar will be on the workshops, including load control, rigging selection, and center of gravity. So I'm going to turn it over again here to Mike. Thank you all again for joining, and we'll get started.
Okay, I'd like to welcome everybody, and thanks for the intro, Zach. And we're very excited to have you join us today. And please make sure that you've downloaded the Master Rigger Workbook. It's a 7-page document that's just select for today's presentation. And in the process of those workshops, we'll be considering items that have to do with load control and proper rigging techniques, and then rigging selection based on load distribution, and then also center of gravity, of course. So make sure you get that downloaded. As we go along, if you have questions, you'd like to type those in and send those in, I will deal and work with all the questions possible towards the end of the presentation. Some of those may be collected together. It may be 2 or 3 questions very similar. Those will be compiled, and I'll do my very best to respond to those. So make sure that you get the questions put in that you'd like, and also be thinking about the impact of the presentation as far as your organization, how these workshops or this type of information can best serve your needs based on your applications and your crane and rigging environment. Also, we have this is a little bit of an overview of who really is sort of the Master Rigger candidates. And in particular are folks that have some course experience in crane and rigging activities. It won't have to be really the Superman of your organization, but there are a lot of folks that, as we've talked over previous webinars, we really want to make sure that we're attending to those 1- and 2-year folks that are going to be growing into the 3- and 4-year block. And there'll be folks that we want to help really take forward in for skills training and skills enhancement. So it's those are great candidates. You can see a whole listing here of job titles of folks that may fall into the titles that you have within your organization or very similar. And nearly every type of industry have a need for folks that have the skills and traits and abilities, knowledge for advanced rigging. A lot of things that we're seeing today, qualified riggers oversee basic riggers. Well, this is qualified rigger and advanced rigger, master rigger, lift director. All those kinds of folks in those industries will really benefit from course information that's contained in a program like this. The rigging subjects that we particularly attend to in this program, and this is offered in Woodland, Washington, Memphis, Tennessee, and also on-site. I'm actually, we're doing a special course for Agrium up in Edmonton, Alberta. Very similar to this, we do this on-site. It takes some preparation and some equipment, but the subject and course content we'll be dealing with in almost every Master Rigger course are the core elements of good rigging and taking them up to implementing engineering principles for laymen. And that's the idea, is to not teach over anybody's heads. It's bring it all down to so we can all understand it and grasp and gather that and put those rocks in our backpack so that we're prepared for any job that comes across to us that we can handle effectively and within control, and using proven principles, good practices, and keeping our people safe. So these are the items that we really focus on, and particularly distribution of load. Of course, the 3 basic elements, the core basic elements of rigging is what's the load weigh, where's the center of gravity, and how are we going to control it. And so those are all sprinkled in throughout, of course, in any Master Rigger course, because those are the core foundations upon which we build a good rigging job and rigging plan. So where these are offered, of course, they can be for at your facilities, in any of our training centers in the U.S. and Canada, And then we do have an e-learning module series that I believe there are 12 different e-learning modules that deal with advanced and master rigor subjects. So it's available to you in a variety of packages and a variety of mediums. So take a look and then entertain how that might best serve your organization. We work hard to provide in the neighborhood of at least 50% classroom information and 50% hands-on information is very important. We like to get dirty and sweat a lot, of course, while we're doing our programs because that's when real learning takes place. Is speaking while doing and defending those decisions all help us in embedding those skills and those pieces of knowledge in us for a long term. So tons of hands-on, and it's really important. You've got to have the equipment, need the play area, need the loads. We use a lot of dynamometers to help prove and confirm calculations in advance. It's a great, it's probably our most fun program, but it's also the most enriching and skills enhancement program that we offer. Particular to this program, we work with chain falls, load transfer using chain falls. You can see just a couple. I'm just going to burn through a number of pictures here, but we're going to have certain loads imposed on these overhead connection points. We integrate dynamometers along with the chain falls to confirm those values. But if this load has to come from this location, make a pass, go through a window, and get placed down or transfer, we know in the old rigging approach, we have length divided by height times share of load weight. And so on both ends of that drifting operation, we always have to be cognizant of what loads we're imposing on those overhead bearing points or connection points. Could be beam clamps that are used appropriately within a given angle, or a hard connection point. So we really want to make sure we don't overload anything, especially our come-alongs or chain falls that we might be using for that. These dynamometers go a long ways to help confirm and validate and verify the anticipated tensions that we're seeing, and we always use those in all of our training programs. And the proper method, you'll see Michael Johnson here is one of our instructors, that we're out of the line of fire. We stand off to the side while we're chain falling in case we ever have any brake issue, slippage, or anything else. This load's making that pass, and we want to make sure that from an operational standpoint, we've got our people really taken care of, and they're off to the side, out of the line of fire, and so that they're away from the pendulum action should any incident occur. So it's all about the safety for personnel, safety for the equipment, and the facility, the building, the location we're using. Another subject just really quickly is load distribution, and we know we've got a given payload, and in this case we've got a car body down here. This weighs about 4,800 pounds, and this being rigged up in a 4-point pick. We're using fixed connection points, shackles, and chain slings. We're rigging up to a spreader bar, or a lifting beam actually, and you'll notice that the load is very high to one crane and very low to another crane, particularly with our pick point. So how do we distribute out that weight of that payload, the weight of the rigging, and also the weight of the beam out to these two cranes that are providing the lift? And it doesn't, it seems fairly complex, but really in the master rigger, it's within a 45-minute workshop. People are ramped up very quickly on how to arrive at those values and those decisions. Here's another knuckle off a 966 loader, and this guy right here is being rigged up. We've got a far pick point up here that we're rigging to, far out on one side, close down on another, and that's going to definitely impose more load to one side or the other. And we want to make sure that at any given time, whether it's a beam trolley transfer, using a lifting beam for reallocating the load to various cranes and so on, we're capable of identifying how much load to each of those cranes is really important to the operators, of course, but it's also important to us for knowing what we've got for our rigging tensions and how we're able to manipulate or control that load through the path. So this is let's go on to incline planes. things get rolled and ramped up, we've got a couple of ramps that we use for training activities. You know, of course, it's going to have a certain height, certain ramp length, horizontal, and certain length on the incline. And that's going to produce greater load for our winch or using for a pulling system up here. And once we get up to the flat, then we've just got W weight times coefficient of friction is going to give us the required force to pull that load. But when we come up an incline, we certainly have some different additional tensions to deal with, up or down, and we've got to anticipate that, make sure that our rigging is right and our winch is capable. And then our load control, of course, in this case, we've got a single steering unit down here and 2 pups, 1 on each end, to make a nice triangular move and sort of the 3-point milk stool rolling system. We almost always prefer rolling with 3 versus 4 rollers to help continue to maintain load to all pick points, all bearing points. Based on the center of gravity's location, we'll decide how much load to that front steering or the rear steering roller versus the 2 on the other end. So we're constantly making sure, what's the weight, where's the CG, how's that affecting my capacity for the rigging I'm attaching or supporting it with. So it's a pretty intense process. Here's another incline, different rolling system. We've got a bar right down here that's connected to those 2 front pup rollers, and we've got a steering mechanism, a steering roller on the back. In this case, this looks like it's, I think this is our smaller unit. This is a 5-ton unit. So we'd have 1 1/4 ton per capacity for each of the 2 front pup rollers, and then 2.5 ton capacity for the back roller that's back over here. We've got another 25-ton set, various rolling sets that are capable of moving a variety of sizes of load. So each time we've got to make sure that we've got the each roller is capable of supporting its anticipated load dedicated based on its position to CG and overall weight. So those are always elements that we're considering and concerned with. Here's a 25-ton roller system under this similar unit. Notice this is a little unique here. We've got to always make sure for jacking and rolling. I want to bring this to your attention. Notice we've got some steel plates we've got cut handles into, but we've got to make a transition, and it's really important. This is an upper flat concrete pad and a slightly lower pad. We've got about 1.5 inch transition to make right at this brake line right here. So we've installed some steel plates for a small rampway to be able to step that load up and to make the transition up so we don't disrupt or interrupt or knock any rollers out from underneath. So transitioning from floor space or from sometimes jumping over expansion joints and all the other elements, a good master rigger is going to take a look at his entire runway and make sure we can make those transitions appropriately, not get the load hung up, not have to jack and reset rollers to a new position because we didn't prepare for this transitional element. So those are all parts of a good master rigger program. We're putting challenges in front of people and making sure they can deal with it, and then teach through and work through all the possible solutions. We use mechanical jacks, and we use hydraulic jacks, and we also use airlifting bags as our lifting systems for all of the programs that we conduct. In this case, we've got a hydraulic jack, always ensure we've got good foundation and good support for it. And transferring, we're constantly using blocking, of course, and instructing in proper methods for block insertion and removal, never getting our hands underneath the blocking, always hands on top, palm down, so that in case we have any jack issues, it knocks that blocking out of our hand and our hand isn't trapped underneath it. So techniques, methodology, all those things come into play when we're providing that instruction. This is an air caster system. We've got a number of these in all of our facilities, and the air casters are placed, you can see right underneath here and right up underneath, and these do have tonnage capacity. This is a 7-ton unit, and so back there will be 4 of these in this case because we have ability through a console system to be able to manipulate the air pressure and air volume to the different air casters. They have a non-skid grip type topper on them, and we're able to hoist or to lift and then manipulate the load through a nice clean surface area we can and do show folks how to take care of working over rough surfaces. Sometimes there are cracks in the floor. We can fill those and tape over them or run linoleum over the top. There's a variety of methods how to deal with some uneven surfaces. But these are great systems for moving in clean rooms and areas that you don't want to do any markings on the floor or floor indentations that might be coming from a Hillman roller or some other rolling system. So it's we work at using a variety of tools and methods to accomplish horizontal load moving as well as vertical lifting and load handling. Of course, angles and tensions based on center of gravity of load. There are, in this case, we have a lifting beam that it has a variety of pick points and pad eyes across that give us an opportunity to put different pick points and different rigging points across the entire top surface of this load. We may end up with a very short leg on one side and a very long leg on the other. Of course, dynamometers will be put into place, but it really makes believers out of people when we take height divided by length divided by height times share of load, and all of a sudden the light bulbs go on and everybody starts to grasp very quickly. Tension does increase as the angle decreases. So great tools and great equipment to be able to use, and this can all be developed at your location as necessary. Lifting angles, of course, are involved out on for standard load rigging with mobile cranes, and these become really great instructional tools and great reminders of tension is increasing as the angle is getting flatter to the horizon. Load control is a huge issue. We do a lot of act investigation, expert witness work, and good rigging methods, poor rigging methods can be imposed at various places, various locations around facilities. And you'll notice we've got a little knuckle arm here for a small loader. Notice we're using a ton of sling protection. In some cases, there'll be cut protection. In cases, it'll be abrasion protection. We have mesh guard, cover, corner max. We use Lenton rigging products, corner rounds, all kinds of things. But how to collect that rigging up at the very top and making sure that there's nothing that can happen that can have that load go kind of ass over tea kettle and end up with the load flipped on us or slip or sliding. We just have to make sure that every time we grab that load, we're going to dictate and require where it's going to fly to and how it's going to, in what orientation, what position. We never want to be surprised by loads upending or flipping because we're poorly rigged. So load control is a big issue for us, and also certainly sling protection is a huge element. So these are all taken into consideration. You also got a big shaft here with some knuckles and gear drive items. You see the center of gravity is right there. And rigging to that CG is really important to get that thing level in case we have to install it in certain locations. So a lot of time is spent with various teams as they are assigned different rigging projects around the yards or inside the building to make sure load control is a very top priority for them while they're addressing a project. And load turning, of course, is a big issue. A lot of slings get cut because load turning takes place. You know, some things that happen, we end up with may end up with a load that looks like this, and unfortunately we've got situations at times where we've got pick points. So we may have a swivel hoist string set that is on the outside, and unfortunately we may end up with slings from time to time that get rigged down to those corners. We're going to upright this load in that direction. So really what needs to be happening, because we know what's going to, as this load breaks over, we're going to turn this load up. We may have a step block right over here where it's going to accept that load so that we don't slam the crane over. And step block will arrest that load from its complete overturn, and it's able to accept that load so it can step up and then lift. So what happens, though, when this sling makes this rotation around that corner and continues to fight as it makes that pass, eventually this sling will be in this orientation. And this is a huge cutting issue or load scrubbing and damage issue. So we really work hard to, let's drop in a spreader bar right here and make the pass, and allow that thing to really rotate completely and cleanly without ever making contact with that load is really going to be the answer. And so you get into some instruction and use of ancillary equipment to help prevent damage to slings, damage and drop loads, and people getting hurt. So slipping in a few, I mean, you can get a 5-ton spreader bar like this for, say $800, and it's a pretty cheap investment, maybe 6 foot, 8 foot, 10 foot, but it ends up as a pretty cheap investment to be able to complement load turning activities in various facilities. So just simple answers that all of a sudden avoid this sling damage and cutting and all kinds of potentials downstream. And I would strongly suggest we take a look at our rigging tool room, our gearbox, our gang boxes, wherever we've got rigging stored, and make sure we've got appropriate equipment to perform the assigned task. So just ideas kind of floating out there. Load turning, of course, this is a 2-crane pick, pick and turn. Notice we've got pick points with extensions out here. We've got pick points, and we're sharing the load with rolling blocks right here, and we're able to pick and rotate that load up. We know we've got X pounds of load for that crane, X pounds of load here, and as riggers, we need to make sure that we're protecting the rigging during this pick and turn process. This load's probably a 33,000 pound load, and we want to make sure that nothing gets overloaded in the process, and we're able to make that turn clean. So this was just done in our yard not very long ago. We had to get this tower section uprighted. So, but multiple crane lifts is really a big deal, and typically we would encourage OSHA calls out for multiple crane lifts as something that falls into what they would define as critical lift, though they actually don't detail that out in many of the documents. But that would be making sure that we've got a lift plan basically for both cranes, how much load will be on each crane based on wherever our rigging is suspended from. So multiple crane picks is a big deal. The issue is we swing away with one crane too far in one direction, and we get out of plumb with that hoist line. We're certainly going to get out of plumb with the other hoist line and potentially pull this crane along with this crane over. So one crane can be doing a lot of damage to its brother while they're making a lift like that. So it's all about orchestration, good signaling, good planning, good route, and setup of the cranes, and maybe side-by-side versus dueling booms where we're facing the cranes to each other. So it takes a lot of planning and make sure, and this part of the Master Rigger program incorporates this type of lift activity. Let's go right ahead. One of the last subjects, winching, of course. We had engineered a number of anchor plates to help secure our winches to at our facilities, and to make sure we can have suitable pulling points, and of course pulling using multi-part lines up, and to incorporate a variety of methods to get loads relocated from point A to point B. Well, we're going to go really quickly now into our workshops, and I'm going to ask you to get the workshop handout that was provided to you. It's a 7-page document. Let's go through that. I'm going to flip to that screen right now, and let's take a look at this. Should be what the cover looks like for you, and it's got it's a little 2-crane pick on the cover right there. This is a little intro inside of that on the page 2, and it shows a table of contents. What we should have in our little handout here is the Journeyman Riggers reference card, the Master Riggers card, load control. We have 3 workshops on pages 5, 6, and 7. So let's take a look then at the Journeyman card. I'll bounce this up on the screen for you. I've got an additional this is one of probably 6 or 7 different cards that are available that we've produced. We've produced it flat for you on a side-by-side for your page today to work through for our workshops. And so there are a variety. I'll bring up a couple of others to you that you don't have. We do have a Rigging with the Big Stuff card. I just put it up on the screen. And this particular card has the 4-inch wire rope slings. It's really with items with 10 ton to 1,500 ton. So it's the big brother to this journeyman card. And you'll notice, if you will, down here on panel 5 for this rigging with the big stuff card, it's not been provided to you. We made an agreement with Crosby. We put their wide body shackles on going up to 1,500 tons. And we incorporate this card, of course, then standard shackle sizes up to 6 inches over here. And we incorporate that in with a workshop example on the back of the card that, in this case, this loads 380 ton. And we ask take through the contents of the card to identify a variety of items that are which shackles should be used at these points based on anticipated load, which slings, round slings, which size shackles, 125-ton spreader bar, big braided wire rope slings, large spreader bar, and then, of course, our top slings. Those are all available by site and selection based on that card. Notice on these 9-part braided slings, I know we've got a number of attendees on the call today that are in this world. They've got 3-inch, 3.5-inch component rope that make up to a 14-inch finished rope diameter, sling diameter that's over 700 ton per vertical. So there are other cards that provide additional information beyond those two that you have in your workbook. I wanted to bring those to your attention. And let's take a look. We do have, of course, a rigging inspection card, multiple colors to help represent what's OSHA and ASME for sling inspection requirements. And so that card is available too. We probably have sold in the last 24 years somewhere in the neighborhood of 3 million cards in 7 different languages. So check with our bookstore. You might find these to be helpful downstream. The card that you have in front of you will be using a variety of sections, and I'll be working with you on which panels we're really going to need for which particular workshops. Of particular interest right now, I'm going to ask you to take a look with me right over here on this panel for the journeyman card, which is on page 3 in your handout. And we're going to take a look at these hitch types right here for just a minute. There are 7 different hitch types, 1 through 7, 8, 9, we're up to 14. So we have 14 different hitch types, and they're all described right down here underneath in that bottom panel. So we have a single vertical, a 2-leg bridle, 4 slings, a 3-leg pick, 3 slings. Here's item number 5, or hitch number 5 is a single basket, and number 6, of course, is a double wrap basket, and so on. So let's kind of keep those in mind. Now let's go over to page 4. Let's go, to page 5. And here's a kind of a good primer for our workshops today. You have 5 different load types that are presented to us. And of those load types, let's take a look at good rigging methods that will accommodate a reasonably good and safe lift. Not about capacity, it's just about load control. So the instruction here I'd like for you to do and work with me is on sample 1 or load 1, which one is the preferred rigging method that will provide the better positive load control. So circle A or B in each case, in 1 through 5, and identify the better technique for each one and circle that, and then we'll review that. And I'll only give you about 15 seconds here to get those marked on your page, then we'll review them for everyone and before we go to our next workshop. So go ahead and mark those up. I'll bring this up for size here. All right, excellent. So we have, let's take a look at item 1, this load. It's kind of an L load, and the center of gravity, of course, is not very happy. It's a little over off to one side there. And, you know, it's going to be the center point here, the center point there, and based on density of materials and so on, so the CG is about there. And the key question you want to ask yourself, anytime you're reviewing a load being rigged, is sort of, we put this into the north, south, east, west perspective, and how I want to relay that to you. Let's take a look at 1A. How many of you would pick 1A or 1B? and I would hope a lot of you picked B as our positive, as a correct solution. So let's take a look at 1B, and it provides good control in this, we'll call this the east-west direction, that the load really can't go anywhere in the east-west orientation or in the north and south orientation. But let's take that same question and look at it on 1A. And in the east-west direction, I'd say that's a big no. This inverted basket right here, you know, if you take a look back on your rigging card, on the journeyman card, let's take a look over here. And let me take you down to panel 5 down here. We're on page 3, panel 5. Just something to bring into mind, coefficients of friction right down here. And look at the coefficient of friction for steel on steel right up here, and we're looking at 10%. And 10% coefficient of friction is very low friction. So let me go back to our little drawing here. And with 10% friction, if we have a steel crane hook with a steel sling, we just have 10% coefficient of friction to help stick that sling to the hook, and that's not very much help, especially if the center of gravity is offset and it's not in a very good place. We're actually working on a court case right now with a jib coming off the side of a hydraulic crane, and the jib looks like something like this. It's pretty long actually, and the guys were rigging it off the side of the boom. A little short stubby jib there, and the bales were set. We'll put one here and one here, and the center of gravity was not really well regarded, and what the guys did was to rig this up in 2 inverted baskets to the 2 pick points, 4 pick points on the bale. So they ended up with a, as this thing came off, of course the crane hook was right here, picked it up, and they tried to pull it off the side of the crane this way, and just the second it left the engagement anchor and hangers on the crane, I'm sure that what you can already identify is this end went up dramatically, this butt section went down, and the slings ran right through the hook. And unfortunately, we had a gentleman that was at this end of the jib hanging on to the end of it, pulling it away from the machine, and he was injured as a result. So this entire unit went up and flipped him, and he's been injured now as a result of this. So inverted baskets are just a killer way to rig. I mean, it's not good. It's we're going to end up getting people hurt in a hurry. You know, I had somebody tell me, don't worry, the load's self-centering. Well, it sure will. It'll do exactly what it wants to do, and you want to be really cautious. So we're going to put a big circle and slash over this thing here, and this is not going to be something we want to approach in any really easy way to get hurt, fast way to have a wreck. So let's take a look at number 2. We got A or B, and I would think most of you had marked B as a provided, the preferred method. Think about that east and west control and the north and south control. That looks good. Sort of this optimum angle right here that we want to be greater than or equal to 60 degrees up here, and that's from the southwest corner to the northeast corner. That is sort of our imaginary line right there. So we've got a double wrap on each end, clustering together those 3 pipe units there. So it's a really good method, and nice tall angle. Everything works best for us. Under 2A, we've got a number of issues here. That inverted basket, let's go back to our rigging card and bring up on our rigging card is take a look at those sling hitch types there. And I'm going to put up a little cleaner series here for us. So take a look at those hitch types there. And if you'll notice, we've got that inverted basket right here, number 14. And right below, we've listed that as number 14, single inverted basket above the center of gravity. 2 legs are taking load, but it's very much a poor load control, poor method for rigging. So we're looking for a wreck when we're getting through that, rigging in that configuration. and you want to be really cautious and avoid that at all costs. It's just a lazy way to rig, and this is a big no. We're going to lose this in the north and south direction for sure. And I would certainly say with this angle coming down, going across to the cross corner and back up, that angle is very flat right there, probably in the 30-degree range. We're very flat, really good opportunity for those slings to slide in. And once the sling slides in, the pipe units can go oopsie-crapsy on us here, and we'll lose the whole bundle. So we've got bad rigging really at the top and the bottom for this method, and it would be really poor way to approach a load. It's really pretty lazy. We just don't really have it attacked properly, and we're not taking care of the rigging technique itself and or load control. Let's take a look at 3A or B. 3A, we've got, this is, if you look on your rigging card on panel 7 and 8, there for the journeyman on page 3, you'll see this as hitch number 8, and this is going to be hitch number 13. So if we evaluate those two, let's take a look. I think we probably all agree. Let's go with A as our preferred method. East and west control, north and south control looks pretty good. This inverted basket on this one is actually a help to us if you think about it. This inverted basket to the left, we've got two short legs on one side, and let's call this 8 foot and 8 foot, and this would be a 16. And that inverted basket, always make sure we take care of the D to D ratio right up here where the sling is going over the hook, unless you're using synthetic rigging with a wear pad or protection. But make sure that this will help equalize the loading to all 4 pick points, and it's a really good way to help lower the loading and tension per leg. The tension is going to be also pretty equalized on B. However, this is okay for east and west, but boy, this is a disaster north and south because we've got these inverted baskets double, and we have a really dangerous and hazardous method. If we'll notice hitch number 13 on our page 3, we're listed as 4 legs take load, but it's a very poor way to rig. It's not something we want to get into, and that's from this illustration right here. We want to really be cautious. That's number 13 is no go. That's a good way to get hurt. So go back to our sketch real quick here, and let's go to item number 4 here. And this is pretty interesting. This is a method that can be used for A or B. Let's take a look, and I would hope most of us would select A as our preferred method. Let's talk about its attributes for a second. East and west control looks good. North and south control looks pretty good. I mean, it's all apexing right up there at the hook. Given angle or length to height ratio and tension, we might only give this credit for a 2 legs take load. Some folks will take 3. Rarely will you get 4 legs taking load because of pick point placement, sling length, etc. So rarely will you get all 4 legs equally taking load, and it might not. But from a control standpoint, we got it. We're good. We're in good shape. This one over on the right here on 4B, let's take a look. East and west is probably not a problem. North and south, that's our problem. And we're doing a couple of things here. One is the sling can actually run through those shackles. Those are running basket hitches. They're actually reeved through the shackles and pulling against those pad eyes. So we have the runnability here is an issue. But even bigger is the load or force that's being imposed on those corner pick points right there. And if we take a look, we actually have a little bit of an included angle right here. And I'm going to ask you to go with me to your journeyman rigging card on page 3. Let's take a look at that guy. And let's look in the area that's called block loading and block unfairly loading. And so if you remember that those slings are breaking through the pick point, and I'll just draw it right over the top here. A sling is breaking through a shackle and breaking back up. So it's actually that shackle for a dead-end connection right there and right here serving as a little baby rigging block. And what happens is it compounds the loading right there at that shackle connection and pad eye. It's a really dangerous way to rig. And we'll call this angle right here 60 degrees for a minute. And if you'll notice right on your chart right there, at 60 degrees, angle, full angle included right there, we have a block factor of 1.73. And so what we're going to do, I'm going to go back over to our drawing, and let's apply that now with knowledge. And we're going to give this load, we're going to say that all pick points are going to be 3,000 pounds. And do the same thing on the other side. So if we had a perfect rigging method and all four legs were perfectly equal in length, everything's good, and our pick points are right, we could float that out to 3,000 pounds per leg, especially if we had sub-links and master links up at the top and so on. We're able to float that out properly. If we apply that 3,000 pounds over here to those pad eyes and shackles right there, what happens is we're going to apply that 3,000 pounds dedicated load to that sling leg, and we're going to use that multiplier. And I'm going to ask you to punch in a calculator or your telephone there. 3,000 and our multiplier for a 60-degree angle right there is 1.73. And we've got an actual load on the pick point, on the bearing point of 5190. That's the compounding effect, and that's happening right down here at the shackle and lifting lug. So it's no longer just 3,000 as we have on the left-hand side on 4A. It's actually almost 5,200 pounds right there on each of those pick points. And we're trying to fold that pad eye over broadside. It's an orientation likely it was not ever designed for. So I'm just going to put the big word lazy here. It's really a lazy way to rig. We need to actually improve that and make sure that we're not compromising the pad eyes, pick points, and not inadvertently increasing the tensions to those. So be really careful. This would be another one of those, boy, stay away from that like in a heartbeat. It's a good way to get hurt. So pad eyes can snap off and loads can come down. So we're going to look at the last one, 5A or B. And let's take a look. I hope most of us would prefer B. East and west control, north and south control. Looks good there on 5A. We have, in this orientation, we'll call this east and west. Not bad, but boy, it's a man-eater here for going north and south. And that one thing to think about is the CG is up here going across to the other sling position, and our bearing points are below the CG. So we have two legs below center of gravity, and it's a perfect recipe for disaster. I've seen this a couple of times. Guys will rig this up, and they'll think it's all happy and nice and lift it straight up, and it doesn't react. Nothing happens. But eventually, the crane's got to take it sideways, and when we go sideways, left or right, that load's just trying to decide, do I fall to the port side or starboard side, and we upend the load, and all of a sudden cut the slings, drop the load, everything goes south on us. So really poor way to rig. A reference point for that on our card is to take a look at this hitch number 2, and we're on page 3. Look at hitch number 2 right there, and just as a point of information, right down below you'll see this 2-leg bridle right here described. 2-leg bridle there. Rig above or below center of gravity, it says above, 2 legs and average leg or average load. But this is limited to above the center of gravity only, never below the CG. 2 legs never below center of gravity. Not a good way to rig. All right, so let's take a look then. Let's go into our next workshop, and we're going to flip over to page 6. And this is a great workshop. I'm going to introduce you to a couple of places on our rigging card. We're going to work through this together. For those of you, as we can build this together, I'm going to bring this up large on the screen, and this is sort of a walk and talk together. And we're going to identify first that the total weight right down here is 110,000 pounds. And you'll notice right below that we have components A, B, C, D, and E. So we need to find out what size the components need to be. And right down below, we need to figure out the anticipated tension for all those components. So let's go back up. We'll write those down as we go. We have nothing to the alternative, but the engineers have assured us that the pad eyes are properly placed according to the center of gravity. So we're all good there. We have equidistant. This equals there. This equals here. We're good there. So we're going to anticipate then, short of any small rigging weight, 55,000 pounds per pad eye. So let's make a note there, 55,000 per pad eye is anticipated tension for A and for B and for C. So I want to write that down below. I'm going to enter that as my anticipated tension area, so please do that with me right down here, 55,000 pounds for A, B, and C, because I'm going to have to size my rigging up in just a few minutes. Now, so before we go over to picking the rigging and its available capacity, let's arrive at all of our tensions first, and then we'll go pick the rigging to accommodate that. So what we're told then, we've got the next item up. We've got a lifting beam, spreader bar right here, and it weighs 10,000 pounds. It's good for 60 tons. So I've got to account for the 10,000 pounds of extra load that happens at this elevation. So right up on top of this pad eye right here, it's got a net load of 60,000 pounds straight up for each end, because I've got my 55 plus 5,000 at this end of the bar makes my 60,000 pounds. But my real question is, what is tension going up in that leg? And that's really the bigger question. So I got to accommodate my rigging for my tension. So we're given this 45 degrees right here. So here's a card that we haven't used yet, is on panel 4, and that's the Master Rigger card. So let's take a look at that guy on page 4, Master Rigger card. It's in the upper left-hand corner of your page. Now let's find the 45 degrees right here, and we have what's termed length, height, and run relationship for 45 degrees is a length of 1414, a height of 1, and a run of 1. So really, what we'll do is we'll take length divided by height is our multiplier. So length divided by height is our multiplier times share of load weight. And that formula, if you want to find that formula, it's right on the journeyman card, which is on page 3. And that formula is on panel 2 right here. So I'm on page 3, second box down, said load factors and weight distribution, and that formula is right up here on the top. And the formula says the length of the sling divided by the height times share of load equals tension. So that is how we apply length over height. And that's a formula location that's on our journeyman card. We're using the number right off of our Master Rigger card. So we're going to be using that 141, the 141 and the 1. And so let's go back to our workshop page. So I have because I really, in my rigging drawing, I don't know what that is, but I know that's a 45 degrees, so I'm going to have 1.414 divided by 1 times share of load of 60,000. And that'll help me find what my tension is. So I'm just going to punch that into our calculator. Let's do that. 1.414 divided by 1 is 1.414 times 60,000. And we've got 84,840. So I need to enter that. I'm working on page 6 right here. So I need to enter that for my tensions. Anticipated tension is 84,840 for each of those two pieces of gear, my shackle and my top sling. So now I know my anticipated tension which I always need before I can pick my rigging. Now I'm going to show you a really cool place on the Master Rigger card that gets us to some really quick planning decisions for how big a rigging do we really need. And that's on the Master Rigger card. That's going to be on page 4. Page 4, and I'll show you on the big sheet, page 4 where we're at, and it'll be over on your right side. And it's going to be this panel right here, inline tension capacity chart. And it's really boiling down a whole bunch of rigging charts and putting into it a half a panel. So I'm going to focus on that for just a minute. So let's get our decisions going right there. So inline tension capacity chart, we're using this panel right here. And we know that we've got 2 sets of tensions we're trying to overcome with our rigging. One is 55,000 pounds, and the other one is 84,840. So I've got to pick my rigging to accommodate that. So question A is, what do I need for a shackle, a load shackle, at 55,000 pounds? And I can slide down that little chart and identify, I'm going to come into the 60,000 pound point right here, and then I've got a box that tells me my wire rope slings or web slings that are flat endless. I've got chain slings, and I've got shackles right here. So I need a shackle, and I'm going to arrive at a 2-inch shackle for A, and a web sling, endless flat web sling. It's going to be a description of a 3-ply, 9,000 pound grade webbing 8 inches wide, and that's B. And then C is going to be another 2-inch shackle again. So I've got A, B, and C identified right there, and a lot of times the manufacturer can fold over the web sling and make it more suitable for bearing into that 2-inch shackle and sew that down for us, or we can also use a wide body shackle potentially for making up that connection. But we've found quickly we need a couple of 2-inch shackles, and we need that 3908 web sling. So let's transfer that to our workbook page. So we'll put that right down, and we're right there. So let's get that listed and get that taken care of. So I'm working with you. Thanks for riding along with me on this page flipping. So I've got a 2-inch shackle, and EN is an endless web sling, and it's a 3908, and I've got another 2-inch shackle here. And we found that the capacity for those, at least stated on the card, is 60,000 pounds minimum. And actually, if we go to a rated capacity table, we'll find that those items probably have some higher capacity, but best available based on a Master Rigger card. We know because this is always a double check. We want to make sure that each of these 3 decisions exceeds the anticipated tension on this other side. So we're great shape there. Now I've got to find some bigger rigging to handle the upper sling and shackle selection that's on the top side. I've got to deal with that sling and shackle combination, which is D and E. Anticipated tension is going to be 84,840. So let's go back over to our Master Rigger card, which is on page 4. We're still on that little panel on 8 right there. And I've got to get up into the next bunch of rigging sizes here. Now 86,000 is our best available capacity to overcome 84,840. So I've got my wire rope selection and my shackle selection. What do we find for shackle size? 2.5 inch. What do we find for the wire rope sling? 2 3/8. And its best known available capacity is 86. In both cases are probably over that, but that's a line in the sand we're able to build into the card to help give us some planning tools for selection. So let's take that information right over to our, and we'll complete our 5-point listing here. So I'm going to use a 2.5 inch shackle, and at the moment I know that it's got at least 86,000 pounds. That's the column or chart point I found that in. And I can use a 2 3/8 inch sling, and again 86,000. And this both exceed our anticipated tension. So at certain sizes of rigging, we may have to be adding rigging weight. I don't think we'll need to at this point. We won't be gaining that much rigging weight above, but we'll be at least right at and above the necessary capacity. So we just found a number of quick solutions for that little workshop problem. So we've got we know we've got appropriate rigging for all of the necessary components up here for the 110,000 pound vessel, and so we're using 2-inch shackles there and here, 3908 web sling EN for endless. We're using a 2.5-inch shackle down here and 2 3/8 at least wire rope sling up there. Always making sure that the sling, make sure the D to D ratio, we never get that crossed up with the shackle that we're selecting. So we're in good shape there. Excellent job, everybody. Let's charge into our last workshop. This is really kind of a cool little identification. We know what the weights of each component are. We need to find the combined center of gravity of this little guy. And I think the easiest thing to do, and let's just we're going to mark out for a moment. Now, you have a little bit of a ruler on your master rigger card on panel 4. Out on the edges, you've got some marking indications out here on this side. And with the item that we're able to send to you, we weren't able to transfer. Some are metric, some are imperial, and of course on one side we got a circumference tape. But just grab a ruler, or I use a metric ruler for doing a lot of this. So grab something close and handy. You can also use this, tear that page off and use these for indicator marks. And we'll just end up working in units, and I'll get you the solution as we go through it. So what we want to do first is we're going to identify the weights per section, and we notice right here leg A was 3,000 pounds, leg B is 6,500 pounds, and leg C is 5,000 pounds. So A, B, and C, those are the weights of each of those pipe sections coming in. It's a pretty large diameter, very light wall, but we need to find the combined center of gravity so we can pick this thing up and mount it to some flanges. So we need to find where is the combined CG of this particular load here. And what I want to do is suggest to you is to take a look with me on the simplest thing probably is to just grab the Journeyman Rigger card on panel 3, and I'll help share with you. That'll be the easiest approach that we can take in this case. And on panel 3, we're in the left-hand column in the load factors and weight distribution section. So find your page 3, left-hand side, and it's the second little box of data down there. And what we're going to use, let's use this known weights formula right down here. And that'll be the easiest thing to help us. Realize and see on the known weights formula, we've got a weight over here on the left side for this little example, and a weight over here on the right side, but we don't know where the center of gravity is. But using those two weights will help us arrive at the CG. So the center of gravity, so we're going to use these two formulas right here, center of gravity in feet from A, center of gravity in feet from B. And we're going to find out where is the CG for 2 pieces, then we'll take that combined CG, go to the third piece. It's actually going to go pretty quick, but what I want you to do is tear that little page off. We're going to use that formula, and I'm going to put it up on the screen for us, and we're going to work through that pretty quickly. So let's take a look at our task here. And one thing that we want to do right off the bat is to use a straight edge and just draw a line from what we're going to mark out as A and B right here. And we'll just make a mark here. From A to B, sorry about I'll make a little clearer mark there, just freehand this, A to B. And I'm going to use a metric on my printed page that you should have also had. When it came off my copy machine, I got that distance and I'm just using millimeters to help for a quick reference, is I call that 42 millimeters. So just stick to a scale, whatever scale you want to use, and I've got 42 units from pick point to pick point, or from center of gravity to center of gravity. I need that piece of information because I've got to insert that in just a few minutes. All right, so we know that leg A is 3,000, leg B, this center pipe section, 6,500. So grab yourself a piece of paper or flip one of these pages over on the back, and let's write our formula down. And the formula from this page 3 right here, that formula section, known weights, that's what we're going to work from. So let's just grab a blank page here, and I'm going to slap the formula down. So CG in feet from A and from B, let's work this together. So weight 1, we're going to assign the weights W1 and W2. So let's do that. I'm going to make this A end is W1 and make this B end W2. And the S equals 42 millimeters. So span is 42. Weight 1 is 3,000. Weight 2 is 6,500. So let's establish that first. So W1 is 3,000, W2 6,500, and spans 42 millimeters. So let's pick up a clean sheet here and work this out really quick. So I've got, I'm going to write this and leave plenty of room to fill in my actual data in between. So I'm going to put this up here, weight 1 and weight 2 equals total weight of the two pieces combined. Then I'll take W2, is what the formula tells me to do right here. W2 divided by total weight equals a percentage, and then percentage times the span equals CG in feet from A. And let's write in the known information that we have. What is weight 1? That's 3,000. What is weight 2? That's 6,500. Our total is 9,500. Excellent job there. So let's take W2, which we know to be 6,500, divided by 9,500. It's going to give us a percentage, and that percentage, we're going to round that out to 0.68. Good job there. And so we'll take down to the third line, 0.68 times the span. We've established that at 42 millimeter or feet, etc. So then we're going to get out of that, we're going to get 29. And I'm going to call it millimeters. And so I'm going to go back to my little drawing. And I'm going to measure out to about 29 millimeters from A using kind of my scale. And I'm going to arrive at a point right about here. And so I've got 29 on this side from A. Now let's do our B side. What I don't know is to double check my math. I'm going to make sure that I can get this correct. I'm going to do how far from B. So let's put that in. I always make sure, just like I did back in school, is to make sure I'm going to work both sides of the equation and capable of confirming it from both sides. So our second formula is W1 divided by total equals a percentage times span equals feet from B. All right, let's slap our numbers in. So I've got, again, 3,000 and 6,500 equals 9,500. Now this time I'm going to take weight 1, which is 3,000, divided by my total weight of 9,500, and I'm going to get that rounded number is going to be 0.32. I'll take 32% of my span of 42, and that's going to give me 13. All right, so here's one question is, does 13 and 29 get us back to 42? And hopefully the answer is yes. So let's go to our drawing page. And so I've got 13 from one side and 29 from the other. And that's going to get me, now that combined center of gravity is right about there for those two components. Now here's something we want to take into consideration. So I'm going to take all this other stuff away for a minute. And that little red CG bullet's right there, and that is the combined center of gravity of A and B. So I'm going to, because I have the magic pin here, I'm going to take these all the way out. They don't actually exist anymore because they're going to be collected right there at this bullet point. And this is going to be my new B, or my new A. That center of gravity is going to be representing my new A, and that's going to actually represent 9,500 pounds because I had my 3 and my 6,500 became that new CG bullet. All right, so A there in that case is going to be 9,500 because I'm going to ask you now to find the combined CG of the entire load. So now this collection point is a new A. I'm going to get rid of the little designation of C down here. And this little guy is going to become B. This is weight 1, and weight 2 equals how much? 5,000 pounds. Excellent. All right. So weight 1 is 9,500 A. Weight 2 at B is 5,000 pounds. Let's use that formula again, and let's measure this distance, and let's see if we can get an agreement here. Whenever I run a straight line right in there, I have a value that I came up with when I did it just prior to the workshop starting, and I've got span equals 58 now. So we're going to call this entire span right here 58. So I got my 3 pieces of information because I'm looking for where is the combined CG now of all 3 pieces added together. So let's get a new clean page in front of us. I'm going to keep that data there. So let's get a new page here, and I'll slap one up on the screen. So I've got weight 1 plus weight 2 equals total weight. Weight 2 divided by total weight equals a percent. Percent times span equals CG in feet from A. Do the same thing on the other side. For B, weight 1 plus weight 2 equals total weight. This time I use weight 1 divided by total weight equals percent. Percent times span equals CG in feet from B. All right, so now I'm going to give you a few seconds here and see if we can come up with our total combined center of gravity. Let's work those out based on the numbers, and I'm going to just put the initial numbers in here. This weight 1 is 9,500. Weight 2 now is 5,000. And we should end up with total weight. And excellent, we got 14,500. Now let's drop down. We're going to impose and employ our formula here, 5,000 divided by 14.5. And just by rounding, we're going to give that a value of 0.34. Very good. And 0.34 times the span. What was the span we called out there? And we said it was going to be 58, just by scale. And now we're going to end up with about 20 millimeters, or scale over to feet, and so on. And that's good for 20. A unit of 20 units from A. We'll go and put that on our drawing in just a second. Let's figure out our right side. So work very quickly there with me if you would. So let's go with 9,500 doesn't change, nor does our 5,000. And that's a 14,500. This time we're going to use 9,500 divided by 14,500 equals a percentage of 66. And now I'll put that 66 times my span of 58, and that'll get me down to a 38. Here's a question again. Does 20 plus 38 get us back to 58? Absolutely. All right, so let's go back to our drawing and put our values there. So we're going to measure along that line from there to there, and we're going to go 20 units from A and 38 units from B, and our CG is right about here. So 20 there and 38 here, and there's our combined center of gravity. Now, why is that important? We want to be able to rig that load from almost any orientation. I'm going to start taking some information out here for just a minute because we've got some nice information to then make probably 5 rigging decisions from. So now we've got the total weight. We know our total weight is 14,500. We know our center of gravity. Let me get rid of these other little guys here for a minute. There's our CG. The CG doesn't have to be a hard point on the load. It can be at floating in space. But it is the point about which to rig. Now we can decide, we want to decide to rig that up from the top down. We'll just assume we're looking top down right here. And we want to build a triangle to support that load to fly it flat off sawhorses and put it and engage it. So really what you want to do is to start with that little center of gravity. And what you can do is, I know this sounds a little silly, but just draw a ring around it, and draw another ring around it, and draw another ring around it. And at some point, what we want to do is find on that ring, where can I rig this up so that I've got some support, creating a triangle to support that load. So I'm going to get rid of those just for a minute. So I got my 3 pick points kind of identified there. So I'm going to rig potentially from here. Here's my center of gravity. Rig that up, and then rig this up, and rig this up. So these are 3 slings, or 2 slings and 2 chain falls with other slings below them, and I'm maintaining that load within that triangle. Though none of the legs are equal, that's okay. It's an odd-shaped load, an odd small weight that I'm really dealing with. But if I can rig that straight down, I've got the loads considerably. I can move this sling down to this position, stretch that triangle out a little bit, and a little better load control or load distribution. So that's from the top down. If that's my center of gravity, I work my way out to 3 bearing points I'd like to pick that up with. Let's take a look. If we want to upend that load, and let's put the CG back in there. So we'll put that center of gravity right back in here for a minute. By the way, when you measure that out, I think I've got 52 units, about 52 units from the top north edge, and I ended up with 24 units from the east edge to see if we all ended up at the same place. So that's just a double check, 52 from the north and 24 from the east. But here's an idea. So we want to upend this load, and here's what I want you to do. Take that center of gravity and sort of take a line north and east and west and north and south. So if I want to rig this up in this orientation, I will peak my slings, and so I can lift it up this way. And knowing the center of gravity, make a soapstone mark right on that pipe right there, go equidistant, equidistant. I can rig this up here, and my slings will meet right over that CG line. That's good. Now it'll be level in that orientation. I can certainly do it in this direction. Make sure your slings peak on that CG line, and certainly I can even do it from here, come around, and I'm peaking over the other direction. So once we've got the center of gravity identified, we can take those slings and make sure that they meet at that orientation line right over that center of gravity, no matter if it's north, south, east, west, top, or bottom, and you've got that load picked, and we're able to control it. But it's all about where in the heck is that center of gravity, and that's what makes everything work. That's what makes everything come together, and we're controlling the load, and we're making it do what we want it to do, and not being at its mercy. All right, Zach, thanks very much for letting me go through the workshops, and I'd like to see if we have some questions that I might be able to help answer, and let's see what folks have to offer up. And it looks like we got a great bunch of folks that have stayed with us all the way through. Everybody's high endurance and doing great, and I sure appreciate the participation. So let's see if we've got any questions today. If not, we'll be rolling out and moving on to other items. So what questions might we have, Zach?
All right. Well, I'll list off some of the questions we had prior to the event starting, but also everyone, you can submit questions in the discussion in the chat box on the right regarding the workshops that you saw. But a question from Roman, what is the best rigging technique for casing pipes?
You know, and I assume that's to lay up and stand up. And if we don't have welded lifting lugs on them, which would be optimum, we always like to have pick points welded on the top end. We can come up with 2 slings and then pick and then rotate that up. If we don't have that, while that puppy's up on some blocking, that's always important. You know, let's block these things up and make sure we've got them supported and off the ground. And so we're able to rig down underneath. But quite often we just need really good high capacity slings. I would always push for using a small spreader bar in this case. But what is not uncommonly done, and you can rotate right on the choker hitch, is we would put a couple of double wrap chokes at this point, go up, make a half hitch, and it's still rated as a choker hitch, and make it such that the sling is biting in into the turning direction. So we're making 1 half hitch right there, and that sling breaks around and goes up to a spreader bar. And that spreader bar only needs to be just slightly wider than the pipe. And do the same thing on the opposite side. So we have a choker hitch starting on the opposite side. It's rigged up, and it also has a half hitch choke point, and it comes up on the left side. And then rig up to our crane hook. That distance right here has to be high enough to pass to the top as we stand that up and invert it. And so we've got securement down here with double wrap choker hitches down here for securement, and then a half hitch for bite and rotation. And then we've got a spreader bar to be able to use to keep the slings away from the cutting edges of the pipe. And then as we lift that pipe up and it's making its rotation, that's rotating about those pick points, and it's able to clear the top of those as we take it to a vertical position. So there's a number of ways to do it. Wire rope slings certainly will work. D-to-D ratio can end up being a problem, but synthetic rigging will work as long as we'll always make sure we got a spreader bar in there to keep the slings away from the edge of the load as the pipe turns up and makes its rotation so we can stab it. So I hope that helps. And there's a lot of ways to do it, but double wrap chokes and a turning hitch right there at that half hitch will help get the job done. Great question, Roman. Thank you very much. Any other questions, Zach?
Yeah, there's an interesting question actually out of New York from Con Edison. Henry put this in before the event started. Is this Master Rigger course specific to any state or cities like New York?
Great question. The answer is no. The ITI Master Rigger program is what you want to kind of note is a skills building program and knowledge base or knowledge enhancement. The New York City Master Rigger licensing is really its own animal, and it will entail some of the subjects that are covered within this course. It could be considered about a 50% prep course for the New York City Master Rigger licensing, but they add into that a number of other elements that have to do with crane reeving, erection of cranes, and a number of other subjects that are really restricted to the New York City licensing. So it is a prep course, but I would only want to tell you that I would say probably about 50% of the content here will help with this licensing exam. The other 50% are other subjects that New York City has developed as a need basis for master riggers to assist and aid in erection and dismantling of cranes, winch systems, tugger systems, Chicago booms, all kinds of other things that they've decided that the master riggers have to be knowledgeable about. So good basic program, good skills building, but we don't cover the entire breadth of all the things covered on the New York Master Rigger License Test. Great question. Thank you for that.
All right, and James from Argonne National Lab actually had a follow-up question that's similar regarding the credentials obtained from the Master Rigger program. Are they recognized in the U.S. or how, and abroad?
Great question. Right now, what I'm going to tell you is sort of in the U.S. that I know of, except for New York City, which has got a particular test, and it's only good for New York City. But all of the programs right now are voluntary in their layout. So whether folks go with a basic rigger, signal person, and those are required trainings for construction, of course, and qualification is required for construction activities, but there's no, you might say, certification is not required, but qualification is required. On the advanced rigger, the master rigger is all voluntary, as well as lift director. And what I think we'll see in the next few years, probably in the 2 to 5 year window, of course, we still have the rigger qualification and signal person qualification for construction, but we'll likely be seeing lift director as probably the next certification that will be out there and available. But I got to tell you, I doubt lift director is mentioned by OSHA in the new construction crane code, but it's not certification is required. But the employer will have to ensure that they're a competent person and qualified to perform that work. But I would suspect there will be at least 2 organizations that will have a certification available for lift director, and that will be on a voluntary basis. I don't think it's going to be certification required by OSHA, but only qualification or competency verified by the employer. So a lot of these are going to get down to the employer designates an employee to have a competency level to a certain status within their organization, but they'll basically be doing that to prove to OSHA that by written testing and performance, they've got folks that they believe are capable and competent to perform certain work activities. But from the certification side of the world, I don't see it right now happening. A lot of private companies, of course, have certain levels and tiers, rigging superintendent, lift director, all those kinds of things for BP or Shell or for Los Alamos, or for all kinds of different organizations. They have a variety of titles, but they're almost all in-house corporate designations. They're not based on a national standard or a national accreditation process at this time. But we'll see a lot of activity starting up and peaking in the next 2 to 5 years at least throughout the U.S. that I know of. Next question.
Yeah, that's good. One little side note on that, maybe for you. Mark from Kiewit asked, with the new OSHA standards requirement of a qualified rigger, what amount of training has been discussed? So maybe we can add on, just finish off that subject, and we can jump back into the technical questions.
Yeah, you know what I will have to say for the qualified rigger status is it's really its ability to perform. And OSHA really is, and what OSHA's doing, a lot of times they're showing up on a site, and they are actually, it's not so much can you hang slings on a hook and then shackles and then pick the load up and go with it. It's what is the load weight? They're asking very pointed questions, and if a rigger is not able to answer that, and he's not able to compute that or calculate that, then OSHA's going to say he's probably not the qualified rigger. They are asking questions today. Where's the CG and what are the sling tensions? And what's happening, I know on a number of job sites, they're asking those basic questions of the qualified rigger, and if he's not able to respond intelligently and reply, here's how I figured the load weight, here's the approximate center of gravity, and here's my resulting sling tension. If they're not able to respond with that, OSHA is taking a very hard view of this and saying, well, that's probably not your qualified rigger. Who's the next person? So that really is achieved most of the time by, and so to get to this ability to perform, typically training is involved, experience, knowledge is gained, and putting it into practice. So we know that that's how we get to this ability to perform, is by having these building blocks under that person. But OSHA is only calling out ability to perform, and the way they're checking that is face-to-face questions of site employees on the rudimentary basics of rigging activities. And I've seen them deny on-site a rigger, and also in numerous cases, and signal persons who are not able to perform according to the requirements. And they said, basically, nice try, Mr. Employer, but they're not able to perform and answer these questions, so we don't believe that they're the competent person or qualified person for this task. You need to get another person, and I need to talk to that person. They're going to go right down the list again. So I gotta, you know, I'm not throwing sky is falling here on top of you, but training is a huge leg of that. And once they get that training and knowledge, like being able to use the rigging cards that we used this morning, and then put it into practice, experience, gain that. Generally speaking, a guy needs to be trained to probably one level above what he really is performing, so he's got at least some of that exposure to that next level of information. If you got some high-end journeyman riggers, qualified riggers, some exposure to the master rigger subject is really valuable. So if you got a master rigger, some of the exposure to a lift director information is really helpful for a master rigger. So, I mean, once you get to that level, some of this exposure to that next level up is really important for them to be able to see how it all fits together. So I hope that helps answer the question. I don't personally know how you can't get the training base in there to not help support the performance, but a lot of employers are trying to do that, and they're not very successful at it today. So they're getting, I'm seeing citations come out because of that, and so we need a training leg underneath there somehow, whether it's in-house or out-of-house, third-party, wherever they get it from. There's probably going to be training to help support that ability to perform. So, good question. Thanks very much for that. Let's go ahead with the next one if there is one.
Yeah, there's a few technical questions here that came on during the webinar. Richard Cravendam, he asked, when you have a 50-ton load and lift it with 4 equal length slings, what safe working load limit slings do you need when this angle with the horizontal is 60 degrees?
Okay. I think the big super question is, are we really counting on 2 legs lifting, 3 legs lifting, or 4 legs lifting? And if the assumption is we've got 4 legs actually lifting, and Richard had this up for a 4-leg lift, I believe, right? So, or a 4-leg lift with 50 tons. And, you know, and really to achieve that, we've got to have some equalization. And so I'm going to draw in here a master link and a couple of sublinks to try to help equalize the loading, so we end up with hinge points at various locations. And then we'll come down with 60 degrees is his question. And this is a little pot-shotting. I know Richard's capability and skill level, so there's no stump the professor time for Richard. He's much more of a professor than I am. We know that the loading, the applied loading, if we take a look at the master rigger card for 60 degrees, we know the load factor is 1.155. So at 60 degrees right here, the load factor is just about 16%. And so we'll go back, and if we take, Richard's given us an example of 50 tons, and so we've got 50 tons on the load. And if you really do give it a pure 4, now that, most people won't do that, and I agree, but we'll use Richard's comparison here. And so we've got a vertical leg loading of 12.5 tons per leg, vertical, and our multiplier, we just found that over on the master rigger card, times 1.155. So we'll impose that. And so inline tension right here, we've got 14.44 ton on the sling, and of course on the shackle connection point, or about 15 tons. So that's about, so we would be grabbing 15-ton shackles, 15-ton slings to be rigged in that leg position right there, times 4 to work our way around that load. But that only satisfies it if we're able to purely divide the leg loading by 4 and end up with the appropriate minimum rigging would be 14.44-ton rigging, slings and shackles. Obviously, the master link's got to be able to carry the entire load. Up here at the top end, this entire assembly's got to be suited for that 50-ton to be able to support the rigging that's coming up into the bottom of it. If we, the other way, certainly I know 2 companies personally, they take the 50 tons divided by 3, and most companies that work to really high ends for safety will take the 50 tons divided by 2, so they'll end up with 25-ton anticipated vertical leg loading times 1.155, and end up with, I'll put that in they'll put in 28 or 29 tons, and that'll be 28.87 tons or 29 or 30 tons per leg, based solely on 2 legs doing the entire lift, and to ensure that they don't get overloaded on their rigging. So great question, Richard. I appreciate it. But that master rigger card, I got to tell you that is a super little chart right there for arriving quickly at load factors based on a variety of angles. You'll notice that those go anywhere from 90 degrees down to 0. Look at the load factor at 5 degrees from horizontal. The load factor is 11.5 or almost 12. So it's huge. So it's really a great tool. And feel free to use this paper version. You can certainly buy the plastic and laminated version from the bookstore. But this is really, if you take the time to really go down through the subject items and go through the different components, you'll find this really super card for making rigging decisions simpler in the field. Any other questions, Zach?
Yep, there's a few more. And Richard, this might deserve just a quick answer, but Richard was questioning while you were answering there, is there a rule anywhere specific that states you must use 2, 3, or 4 slings?
Not to my knowledge. I noticed it normally will end up as a corporate decision. That's a great question. So using 2 legs or 3 legs or 4 legs, wire rope sling sellers and web sling and round sling folks sell slings based on the 4-leg capacity. When they market 4-leg bridles in the U.S. and Canada, to the best of my knowledge, they'll market it for 4 legs taking all and sharing all parts of that load. Obviously, the alloy chain folks limit their 4-leg and 3 legs to only 3 legs capacity only, and that's pretty standard in North America. And then the metal mesh slings work on single leg capacities. I need to throw in here rope slings. Synthetic rope slings are over here in the 4-leg as well. So 1 leg for metal mesh, because they're really only designed for basket or choking, and that's all they're permitted to be used. And it can be used off a spreader bar, but they're not an incline angle loading because their profile of the metal mesh won't permit that. I will say that the corporate it is our corporate position, as well as probably 50% of our corporate clients restrict themselves to a 2-leg lifting, and so it's a practice, but it's not really an OSHA regulation or an ASME document to my knowledge. There may be an API document or Singapore requirements for MOM, Ministry of Manpower, or Australia may work at different design factors or different leg loadings, maximum permissible, but it'll be by country specific and or by corporate. Great question. I do appreciate it. Go ahead.
Okay, we have 2 more questions that are
all right.
relevant. And Dale Thornton from, looks like Hanford Nuclear Facility. What do you think of using both hooks on the same crane to upend the pipe or tank you just described in the workshop? Many folks are against using the whip line as the tail when upending an item, all capacities being within the charts.
Okay, very good question. And under for ASME B30.5, the current edition, I believe, is a 2011 edition. they are in current discussions. That does not address this current edition does not address that, but there are new proposals currently under discussion, and that's just strictly proposal format for using both main block and auxiliary block for uprighting loads. And I can't tell you at the moment whether it's going to survive the voting, and it's going to be probably another 3 years before we would just identify. And what has to happen here is it ends up going through the 0.5 subcommittee. It comes to the ASME, the B30 main committee. If it can survive there, it'll go out for public review and through the ANSI approval. So we are many steps away from actually getting that done, but I will tell you it is an absolute hot topic of discussion. And what I think they're really proposing is that you must have, to make this happen, you must have load indicating device, whether in the crane or on the hook, and at the wheel or at the option of the operator be able to identify and determine the actual payload weight for each hook. So what they're doing is to make sure you've got a crane scale, load moment indicator, LMI, dynamometer, something that you can have at will punch a button and find out what's on my whip line, punch a button what's on my main hoist. That is the approach we're trying to take right now to help protect. And you must have a agreement or provision that it must be okay per the manufacturer to use the crane in that configuration. Some will say yes, and some will say no. So based on the crane and its position, configuration, some manufacturers will say we'll give allowance for that two hook pick and turn using main block and whip line, and a few might likely not. So there are going to be a number of hurdles to get over, and this is really, if you have an opinion about it, drop me an email, and if you'd like to get in on any, not so much discussions, but I can put you in to contact with some of the committee members who are in those discussions. Drop me an email at mike@iti.com, and I'll at least put you in touch with some of the folks that are on the subcommittee for making that decision, and they might be able to kind of keep you up to pace as where do we stand now? Do you have a strong opinion about it, for or against? And might even, certainly visitors are always welcome to the 0.5 subcommittee. So, you know, if you've got an opinion, let's share it and bring it forward, and we would love to hear what you have to say about it. But I think it's also important to hear what the industry experts, because there's probably 15 members on the subcommittee and another 40-plus members on the main committee, and they all want safety as the first element. But there are provisions that would allow for that. Can we do it safely? And that'll be the big question. And with those subject matter experts and industry folks, if it can be determined, and by the manufacturers who also sit on the subcommittees and main committees, if it can be done reasonably, well, safely, they'll likely promote that as an allowable event. So get a hold of me, mike@iti.com, and let me know if you'd like to get in touch with some of those folks, and I'd certainly hand you over to them, and you can have those discussions. I appreciate it very much. Okay, Zach, last question.
Yep, last question from Anthony Munoz from Kiewit. We appreciate the questions, guys. Do you have a practice that you would follow in regards to what percentage of working load limit you use on rigging hardware? In other words, is it acceptable to use 100% of the working load limit if it is in good working condition?
Absolutely. Yeah, we've always been a believer in making sure that we have full capacity, and so I'll just bring the hardware up here. If so, when we know we've got let's say 7.5 ton for a 1-inch shackle, or 8.5 ton for a 1-inch shackle, or 12 ton for an 1.25 inches, it does have a design factor, 5 to 1 or 4 to 1, or 5 to 1 or 6 to 1 in those ranges. And if I need a 12-ton shackle for a 12-ton connection, I have no problem rigging right to that number. If I know here's the other side of that. if I know I've got 12.2 ton load or tension versus 12-ton shackle, I am immediately in violation both for OSHA and ASME. So it's what can I justify, what can I defend, and if I'm at my tonnage capacity with that shackle, I'm good to go. The reason the design factor there, of course, is for wear, metal loss, wear, and use that causes some loss of cross-section and shock load. And those are the two big reasons that we have design factors in almost all of our rigging, to allow for some small amount of wear before we have to take out of service, not deformation, and to because we know that loads end up with some dynamic loading. It might be 1.1, 1.2, 1.6 times actual payload, but we end up with some shock load just from normal, natural hoisting and lowering. So we know we've got to have those design factors in place. But that design factor is there to help absorb for that normal load handling activity. It's okay to do that. I mean, it's fine. And we don't preach that you need to be 1 ton above or 2 tons above or 10% above or 50%. We don't preach that, and nor does anybody impose that from an OSHA ASME standpoint. Rigging right to the capacity, right to the known load weight with the right tonnage capacity shackles is perfectly fine. That also holds true for the rigging, for the slings. One thing that as you start adding rigging, you start adding weight, and you're going to have to count for that or compensate for that. But it's okay to rig to the known capacity if we're within its rated capacity. That's all it says. The main big word that OSHA uses is, in ASME, not to exceed. And that's always the big verbiage. And so once we've got that in mind and we can say, yes, we maintain within the capacity of that rigging, we're good to go, even though we know we're going to have some dynamic loading. That's part of what if you're doing demolition work, I think it's prudent on us to ramp up our rigging sizes because we're going to know we're going to get really drastic dynamic loading, and that's when we upsize the rigging some. But normal lifting, normal operating speeds up and down, the rigging should easily be able to handle it and not walk away with any deformation as a result of standard load handling. Great question. I do appreciate it. Okay, Zach, we do very much appreciate everybody's participation and have enjoyed today, and I do appreciate the questions very much, and we have really enjoyed the time with you. We've got a great number of folks that started with us, have finished with us, even though we've gone to quite a distance here for our program presentation. You'll be getting additional announcements about future webinars that will deal with a variety of subjects from our organization. We sure appreciate you sharing those with others and participating with us again in the future. Zach, I'm going to give you the last word, and thanks very much for allowing me to participate today.
All right, thank you, and thank you everybody again. You'll be getting an email of how to access the presentation after, I think about an hour after this thing closes, and then you'll be also able to download that, but also view the recording or send it to folks that missed it. So enjoy your day, enjoy your week, and thanks for attending. We'll talk to you soon. Thank you.